the Xamarin University Lightning Talk. Today we're going to talk about OAuth2 and OpenID Connect. And in particular, we're going to talk about how it applies to you when you're programming for mobile. And while we'll have a lot of slides and a lot of theory today and not too much code, I really encourage you to stick with this even if you've already implemented an OAuth2 client before, because there is a lot of bad advice out there on how to do it. And we really want to take you through the proper way to do it and give you a basic understanding of why things are the way they are in terms of implementing OAuth 2. And if you really want to get down to coding, don't worry, we're going to have a follow-on lecture where it's all code and it builds on the concepts that we're doing today using Xamarin Auth and Google APIs. We're going to start with an OAuth 2 overview. And since a lot of the OAuth 2 specification was originally created with the web in mind, and for that matter, a lot of the actual documentation you're going to run into out there was written with the web in mind, we're actually going to start with a discussion of how OAuth 2 applies to the web and applies to, say, website developers. And then we'll see how we have to adapt that and how we have to make certain compromises when we're actually developing for mobile. So we'll look at those two steps. So first, the web server. And we start with a typical scenario where we have just an end user sitting in a browser, and we have a web server, in this case cleverly named ourWebServer, and we have normal traffic between the two. The thing is, at some point, we realize as a web server developer or a web app developer that we want to do things on remote services such as Google or Facebook on the user's behalf. Maybe we want to add something to the user's calendar that's relevant to our app. Or maybe we need to send email on their behalf or post to Facebook, whatever it may be. So once we realize we want to do that, we have to figure out a way to actually talk to those services on our user's behalf. And so a naive approach might be to access this third party, and we'll use Google as an example for the rest of this lecture, but to access this third party by taking the user's username and password and then spoofing the user to Google and just pretending to be the user while talking to Google servers. And then of course we could just access their API using the session key. But of course Google will not accept this at all, and for that matter our users won't accept this at all. And really we shouldn't even want to be in this business, because let's say that the user did give us their username and password and then something happened to their Google account. They're going to end up blaming us, and we don't want anything to do with that. So instead, we take an approach where we actually access Google using an access token that can represent the user's authentication. In fact, the access tokens can even represent our own client application's authentication. And that means not only would Google or any service provider be aware of what users' data needs to be accessed and be aware that they are appropriately authenticated, they'd also be aware of what client applications are actually doing the data access. Now, in order to get that token, we actually present a proof to Google. And again, I'm using Google as a stand-in here. This might be Google, Facebook, Twitter, or any small web service out there that just happens to be OAuth compatible. So we present proof, and in exchange, we get that access token. Now, that proof can take many forms, and it could represent the end user, it could represent the client application, or it can represent both. But the type of proof that we send and how we send it is known as the grant type. And the OAuth 2 actually supports many different grant types, and we're going to talk about a few of them today. No matter what grant type you use, you're going to send that proof and you're going to get an access token in return. Once you have that access token, once again, we're able to access those secured APIs. Now, the first type of grant type we're going to discuss is the authorization code grant type. And in fact, you'll see this one documented most often, and that's why we're going to address it first. Now, certain resource providers, a resource provider is something like Google or Facebook again, will actually imply that the authorization code grant is the only grant type that exists within OAuth 2. That, of course, is false. As we've discussed, there are actually several grant types in the OAuth 2 specification, but authorization code grant type definitely is the most common, so we're going to address it first. So back to discussing our scenario where we have normal traffic and need to get that proof over to Google in order to get that access token, we need to start addressing how we get that proof in the authorization code scenario. And so we need to get the authorization code. The way we're going to do that is we're actually going to have the user log in directly to Google and have Google send the authorization code back to us. So the first thing we need to do is actually send the user over to Google. And we do that with either a 302 redirect or with a hyperlink. It doesn't matter as long as ultimately the user's web browser is actually at google.com. And the reason for that is we need to make sure that they're only giving their username and password to Google. Again, we don't want to be in the middle of that and risk being liable for something happening to their username and password. So now the user's web browser is actually pointed to google.com and they see a login. Now in the query string that we sent them, that we sent to Google via the redirect, that query string actually contains our client ID. So Google is fully aware of what client app is actually requesting login. We also send a series of requested accesses, things that we want to do, like access the user's calendar or write email on their behalf. We request those accesses, and those are known as scopes. So the user logs in, and the user consents to those scopes that we request. Google usually will actually present a page that says, our web server would like to send email on your behalf, view your calendar. And so the user just says, okay, I consent. At that point, Google redirects back to our website, and that query string will contain the authorization code. And so now this is a code that indicates to Google that we have a logged in user and that user logged in to the client ID that we sent over. Now, with a logged in user and an authorization code that's recognized by Google, we can go and submit that as proof to go get our access token. So we send that authorization code over, but we also send our own app's client secret, because that now means that our application also is authenticated, because that secret is essentially like an application's password. So the auth code plus the secret are proof of both the user's identity and the client application's identity. So the access token that we get back can now be used to identify both user and client application. And with that, we're now able to access those secured APIs, and Google's able to identify exactly who's doing it, both the user and the client application. The pros of this approach are that it's completely secure. We've actually authenticated both the user and the client application, and that means we can monitor API usage both from the user standpoint and from the client application standpoint. This is important to providers like Google who actually charge for some of their APIs. So they may be charging client applications a certain amount of money for a certain number of API hits. Contrarily, they may be charging end users a certain amount of money to store a certain amount of data or to read a certain amount of data or what have you. And so by being able to monitor both the user and the client application in a highly secure way, Google's able to track that and be exactly certain that they're charging the right people. Now, the only real con of this approach is that you have to be able to fully control that client secret, because it is essentially the password for a client application. Now, the user's password is never at risk because we actually send the user and their browser over to google.com, of course using HTTPS. So their username and password is never at risk. So we can really use this for anything where we can make sure to keep our secret secure. If we can manage to keep our secret secure, this is a great solution. Any scenario where our client secret might be compromised, however, this is not an ideal solution. So that's what we have to watch for. So then how does this apply to mobile? Well, if we go back and look at the scenario we were just talking about, this authorization code grant type and the flow that goes along with it, can we simply adapt this to mobile? Can we simply change the browser to a mobile app and pull the web server right out of the scenario? Well, let's take a look at what that looks like. So now we no longer have to do a redirect to get the user to Google's login page. Now, we still need to make sure that we're never touching the username and password. So the technique here would be to have our mobile app host a web view, and inside that web view, the address would be Google's web page, or we could even open an external web browser. But either way, we open a web browser directly to Google's login page, still putting in the query string, the requested scopes, and our own client ID. And the user still logs in and consents to the scopes that we want. Again, things like posting to their calendar or reading their email. Google then has to redirect back to, well, something. Of course, we don't have a web server anymore, so they can't redirect back to our web server. But guess it doesn't really matter because we control the browser, so we could just read the query string when they're redirecting back to some placeholder. That part's fine. We have the authorization code then out of that query string. So then we take the authorization code and our secret and go to trade it for, oh, well, wait a minute. We have our secret right there. We need our secret to get the access token, but are we going to put our secret on the mobile device of every single user who ever downloads our app? Well, that's not very secure at all. They can decompile the binary. Even if we encrypt it on disk or encrypt it in our binary, they can do things like memory dumps. Then they'd have access to our client secret, so that doesn't work at all. We really can't treat anything as secret if it's on hardware that we don't control. So this approach doesn't really meet that requirement of keeping our secrets secret. So since we're exposing our client secret there, and even our access token is somewhat sensitive since it does represent an authenticated user, an authenticated client app, we don't want people making changes to the user on our behalf with that access token. But really the client secret's the thing that's so highly sensitive. So we don't want people making API calls in our name, so we really don't want to do this approach. So how can we make mobile OAuth secure? Well, we honestly can't. We can never protect a private key on a device that's not under our control. That means we can never make it completely secure using just mobile to a third-party provider. So, all right, how about good enough? Well, we can look at good enough. We get good enough typically by going for the implicit grant type. And so the implicit grant type, we still start out the same way. We request the Google login page. We include our client ID and our requested scopes, and the user still logs in and consents to those permissions that we requested. This part changes a little bit because Google, when they redirect to us, they redirect to something that they know to be a placeholder URL. It's not even really a proper HTTP URL. It's a literal placeholder URL. And in that URL, they actually put the access token in the fragment portion. So two things to note about what I just said. They don't give us an authorization code. They give us the actual access token right there, right off the bat. And they put it in the fragment. That's the portion after the hashtag. The reason for that is just a little bit of added security, just in case that somehow ends up getting posted to a server somewhere. Well, the fragment portion never gets included in a request to a server. That always is for processing only by the web browser. And so that's just a little bit of added security. So we get that fragment. It is the access token. And so with that access token directly, we can start hitting secured APIs. Now, the pros of this approach are our client secret isn't used and therefore it's not at risk. We also haven't authenticated, so if someone does something in our name, we usually cannot be implied to be liable because even though we included our client ID is a well-known value that anyone can take. And we never actually included our client secret, so we never logged in. It would be just like giving a username but never giving a password. So liability is not usually implied. And the other pro of this is that it's just a much simpler flow. Now, the cons are of this, we didn't authenticate. We never actually gave our client secret. Well, that meant it wasn't at risk, but it also means that these calls are being made with our client ID without ever actually proving that we're the correct client. And so if we're allowing that to happen, we might not be the only one doing it with our own client ID. Someone else could be doing it in our name as well. And while usually, since it's not authenticated, we haven't implied liability, it's not a guarantee. Some naive service providers may still assume that they can hold us liable, and that's not really a fight we want to necessarily have to be involved in. And also, since we haven't actually authenticated, any kind of client app tracking is really not reliable. We can tell who claimed to be a given client ID, but not necessarily that they really were. So, client tracking for purposes of just plain knowledge, but even more specifically, things like charging for API usage or rate limiting certain APIs is something that really isn't a good idea when the APIs are being accessed using the simple implicit grant. Note, the user is still strongly authenticated, so we can still rate limit how the user accesses APIs, and the provider can still charge the user appropriately. It's just that they can't necessarily tell what client applications are doing what. And that final bullet point, the reason we made it big and bold and red, is just to once again drive home the point that some naive service providers may not understand this process. And they may be charging for their APIs even though they're not properly authenticated. And they may be making them available where they're not appropriate. So just watch out for that. Hopefully, most service providers, in a situation where it's not appropriate to use soft authentication, are not using soft authentication. So, where should we use the implicit grant type? The best use case for it is simple authentication. In other words, you have the user logged in, and the only actual access you're requesting on the user's behalf, the only scope you're requesting is user info. So you get your access token and you call the basic info API and you get the user's username and email, and that's all you ever need to do on their behalf. That's perfect. That's perfect. You're now able to tell in your mobile app who that user is, but you're not actually changing anything on that user's behalf. You're not doing anything on that user's behalf on the remote servers. That's a great use case for mobile and implicit grant. Some other good use cases can be if you have unlimited or very, very high limit APIs where you're not worried that if someone is illicitly using your client ID that it could result in devastating charges or discontinued access. And also you want to make sure that the APIs that you can access on a user's behalf are low impact APIs, because if some other bad actor takes your client ID and does high impact things to a user's account, you're still going to get partially blamed even if it wasn't really your doing. And so, do not use for very rate limited APIs or APIs that have a high impact on the user information. Do not use where you need a very accurate log of the client application's API usage, because you don't necessarily know who's using that client ID when we're not also using the client secret. What if you really need high security OAuth and you're using mobile, right? You need to access sensitive or high impact APIs, or you need to access APIs that are being charged for. Well, the only really safe way to do this is to go back to the authorization code flow. And in order to do that and to keep your client secret safe, you're going to need to get a web server of your own and put it in the middle and proxy the calls to those sensitive APIs. Then once again, the client side only sees an authorization token. Meanwhile, the secret and our access token are safely dealt with on our server side. So now, some odds and ends just to close out our OAuth2 discussion here. Another grant type is the resource owner password grant. And this is a grant type you're going to use if you control both sides. So you have a mobile app and you want to authenticate users to your database on your own web server. You have a database of username and passwords, and that's how you want to authenticate them. Well, simply the proof that you send for your access token is going to be their username and password. And here you actually will control the username text box and the password text box and just send them along. And this is simply called the resource owner password grant. Okay, this is actually now the way that ASP.NET Owen by default does username and password authentication. So when a user on an ASP.NET website logs in using username and password, behind the scenes it's actually using OAuth2 and the resource owner password grant by default. Another type of grant type is the refresh token grant. So all of the other grant types that we've talked about, in addition to having as their payload an access token, they can also deliver a refresh token. And so when we get the refresh token, we'll end up making that much longer lived than an access token. So an access token might have a lifetime of minutes, hours, or days. A refresh token might have a lifetime of weeks, months, or a year. And when our access token expires, we'll then take the refresh token and use that as proof to get another access token. And so in that second scenario, we'll be using the refresh token grant in order to use that as proof to get another access token. Now, we won't use this very often, but there are some very specific circumstances in which this can reduce your attack surface and increase your security. So now, we said that this talk is about OpenID Connect as well as OAuth2, and really we're only going to have this one little slide about it. But the thing is, OpenID Connect is really just a special case of all of the OAuth2 stuff we've discussed already. It adds some additional specifications and some additional requirements, but it essentially builds right on top of it. So if you're following the docs for an OAuth2 connection to any of your third-party APIs, this is all kind of one thing, and it's all going to work if you understand the OAuth2 stuff we've discussed today. And finally, just to make a liar out of everything else that I already said, it turns out Google has one additional grant type, one additional workflow that looks exactly like the bad way to do authorization code grant, where they actually have you put your secret right on the mobile device. Well, this is very specific to Google, and they fully acknowledge in their documents that the client secret is not secret in that scenario. So you don't have to worry about being liable. You don't have to worry about the fact that, hey, I used my password or I put my password in a compromised situation. That secret is generated just for your mobile devices, so you're not going to have to worry about it having anything to do with your other API secrets. And Google acknowledges that it's not a secret. So otherwise, when using this flow, it looks exactly like our authorization flow code. You get an authorization code as part of that placeholder redirect. You trade that and your secret for an access token, and then you can access the security APIs with this. This is what Google's login control uses behind the scenes. So you might want to know about it for that reason. They have a login control available for both iOS and for Android. And that's the main reason you might want to know about this particular flow. And those controls actually use a little bit of additional wizardry, like checking the bundle ID or using the key store in order to try to add just a little bit more security over just having a random sequence of digits as a client secret. Otherwise, it's a little bit more complex and adds no real advantages and no real additional security over the implicit grant type. So in general, if the options are 50-50, I would still recommend going with the implicit grant type. Okay, if this was a little slide heavy for you and you wanted to jump into code, I really recommend attending the follow-on lightning lecture where we build on these concepts, but we spend the entire time actually implementing this, accessing Google APIs using Xamarin Auth. That lightning lecture will be coming shortly. Otherwise, I really appreciate you guys hanging out and listening to me talk about OAuth2 and OpenID. I hope you got something out of it. Feel free to email me at jasond@xamarin.com if you have any questions about this. Thanks a lot.